Woo-hoo-hoo. All right. Let's see here. We got some 6.4. Graphing sine and cosine. Now, you've graphed sine and cosine before. We're going to do a little bit of review of our parent functions. So let's just get to it. I'm too excited. All right. So when I'm graphing here, we got y equals the sine of x. I like to start with some ordered pairs. Let's think about our unit circle for a sec here. Okay. So let me select a pen. There we go. Let's start with 0, right? So sine of 0, that is going to be 0, right? Now our next quadrantal is going to be pi over 2, and that's going to give me positive 1. And then when I get to pi, I'm going to have 0 once again. Then if I have 3 pi over 2, I get negative 1, and then 2 pi all the way back around, I get back to 0. Cool. Well, and I've got these on my tick marks on that graph there, so I can just go ahead and graph these ordered pairs just to give us a little bit of a, actually, no, I'll go by ones. 1, negative 1. So I start at 0, 0. I'll switch to purple now because that sounds like fun. So 0, 0, then I had pi over 2, comma 1. And then I had pi, comma 0. And then the 3 pi over 2, comma negative 1, and then 2 pi was back to 0. So what we see here, woo, little squiggly there, that is one period of this periodic function. So really this is going to continue on forever in that pattern, okay? So let's just look at this portion for now and start talking about our domain and range. Well, for domain, I said that it's going to continue like that forever. It's just going to keep on doing this. In fact, we could also add on, and I'll do a different color for this so we can focus on just the one period. I could continue on in this pattern forever and ever and ever. Oops, that should be right here. My apologies. There we go. So it'll just keep on doing this wonderful little wave. Well, if I'm talking about my domain, if I said it keeps going on forever and ever and ever, my domain would be all real numbers or negative infinity to infinity. Now for my range, how high and how low is it going? Well, it's getting up to 1 and down to negative 1 for this particular one. So I'd have from negative 1 to positive 1. All right. And then my period. Well, how often does it repeat? How frequently does it repeat? Well, that's the one section there. And in this case, we can look at this, the purple section there from 0 to 2 pi. So it takes 2 pi until it repeats. Awesome sauce. Let's go to cosine now. So for cosine, we can go through the same exact process. I'm going to pause for a sec. And here are the ordered pairs associated with cosine, right? I'm using my quadrantals once again. That's my x coordinate when I'm dealing with the unit circle. Okay, so at 0, that's going to be 1. Cosine of pi over 2 is 0, so on and so forth. So now let's plot these points just like we did with the other one. I'll pause again to save a little time. All right, and there we have it. That red section is what we did for our ordered pairs there. As you see, it goes from 0 all the way to 2 pi. So once again, we can even jot that down. 2 pi is going to be my period, just like the other one. That's how long it takes to repeat itself. And then I did the light blue on what's outside of that one period. And as you'll see, I actually added on a little bit over here as well with that light blue to show that, hey, that's when it starts repeating itself again. Should have done that in the other one, but I did not. All right, so there we go. Now my domain and range. My domain, it goes on forever and ever and ever. So that is negative infinity to positive infinity. And then my range, once again, is from negative 1, including it, to positive 1. Lovely. Wonderful. Fantastic. One other thing I did want to note when graphing these, if you graph one period, oftentimes I'll see students do this. Then they'll come up on the cosine graph, they'll just like flare it way up, and they'll flare it way up. That's not what that graph is doing. That graph is coming back down. So that's why you'll see the red graph, how I have it coming back down, all right? Some subtleties in graphing, but, you know, we want to be classy here. That's a classy way to graph our cosine function, and, in fact, the correct way. And we have a few follow-up questions here. So what is the y-intercept for the graph of the function y equals sine of theta, or sine of x, which we did earlier, but we can use this graph. So my y-intercept, where it crosses the y-axis, is at 0, 0 for this one. Next one, for what values of theta on the interval negative 2 pi to 2 pi does cosine equal 0? So from negative 2 pi, that's all the way over here, we've got negative 3 pi over 2, Then we've got negative pi over 2. I'm not a huge fan of the slashy fractions, but I'm working with the room that we got here. They take up a little less space. Then we've got at pi over 2. And then we have 3 pi over 2. Okay. Now, the last question here, it says, for what values of theta on the interval negative infinity to infinity does cosine of theta equal 0? Meaning theta is unbounded, right? We're just going forever and ever and ever. So what we're going to do is we're going to pick one of those values that we just listed. I'm going to pick the pi over 2. It's our smallest positive value. And then we're going to add, well, how often does this repeat? Well, when we start at pi over 2, how far until it gets to 3 pi over 2? Well, we're adding 2 pi over 2, right, to get to 3 pi over 2. So we're adding pi till it equals 0 again. So I add pi, but we want that to happen all the time. So we could do pi times k, or we could say k pi. So some number k, positive or negative, multiplied by pi, some integer and then that will give us our every 0 to infinity and beyond. Okay? Awesome. All right, so that second part there, that one we find out, well, how long until it equals 0 again, or whatever we're asked for. And then we have that k, that constant multiplied to that pi in this case. All right, onto our amplitude here. So the amplitude, A, of a sine or cosine function is our distance from that midline of the graph. Right now we're dealing with our x-axis, how far away it is from the x-axis. But when we start dealing with shifts up and down, our vertical shifts, then we're going to have to focus on that midline. So I think it's best just to think midline for now, okay? So one way to do that would be to take your max minus your min, divide that by 2. That's your amplitude. Oftentimes we can also just kind of see it based on the graph. Also, you'll see that it's the coefficient in front of that sine or cosine function. So if you're given the equation, you could see it from the number that's in front of your sine or cosine function. If you're given a graph, you can eyeball it based on the midline and how high up it goes or how low it goes, or you can do the max minus min divided by 2. A few ways of computing it. Awesome. Big thing to remember, that amplitude is always a positive number, okay? Always a positive number. If there's a negative, that's a reflection. It's something totally different. The amplitude is always a positive number. Even if it was a negative 3 sine of x, the amplitude is 3, okay? That negative is a vertical reflection. All right, period. The period, notated with T, capital T, is the length of one cycle of the curve, like we were talking about, right? So one full cycle. For our sine and cosine parent functions, that is 2 pi. But we'll start dealing with some period changes, and that will change from, say, 2 pi down to pi or whatever. But we'll get there soon. And this is a lovely little representation here of our period from, until it repeats itself, and then our amplitude there showing how high up it is above that midline. Let's keep it going here. So if we have omega is greater than 0, that little W looking thing, that's Greek letter omega, lowercase, right? The amplitude and period of y equals a sine of omega x and y equals a cosine of omega x are given by, the amplitude is the absolute value of a, okay, right? Amplitude is always going to be positive. And then our period, t, is going to be 2 pi divided by omega. So here's the thing here is variables are rather arbitrary and can be, you could see them in different textbooks and things like that. So most textbooks and what you've been exposed to thus far is this one here where we have A, B, C, and D. Okay? Now our textbook and our online resources that we're using frequently use the lowercase, that omega, and also either you can pronounce it as phi or phi. Not fo or fum. Just phi or phi are both correct pronunciations of that one right there, okay? I did just use the Google Internet Machine to check and see if there was a correct pronunciation, but it can be phi or phi, not fo or fum. Okay, lovely. So you're going to see in our textbook the omega and the phi or phi, and then you'll have that A and the B as well as you see here. So a little bit irritating, a little confusing, but hey, as long as the variables they're saying what they're used for, it's all fair game. okay? So the important part is being able to identify things like your amplitude, your period, your phase shifts, your vertical shifts, your reflections, right? So let's go ahead and do that. So in example A here, we've got that 5 out in front. That would be our amplitude. So our amplitude, that's going to be 5, all right? Always positive. Now our period for this one, well, I would take 2 pi and divide it by that coefficient in front of the x, right? Based on how these formulas are written. So I have 2 pi divided by 3. And that's literally it for that one, okay? No big deal. Now the next one we got, fractions. First off, our amplitude, it's going to be positive 2/3, right? Positive 2/3. Then our period, well, I'm going to have to take 2 pi, I'm going to divide it by pi over 3, which is really like multiplying by 3 over pi. And if it helps, you want to throw that over a little 1 there, because, fractions can be scary. Go for it. So now we're just multiplying across, but I'm going to simplify first, cancel the pi's, and I'm left with 6 over 1, which is just 6. So my period for that one is just 6. Okay. There are some nasty ones you got to work with in my math lab, where the period is not something that's nice and friendly, like 2 pi or pi. There are going to be some weird values. Last thing I want to address with this one is that negative out in front. That is a vertical reflection. Okay, it's a negative outside of the function, so it's a vertical reflection. If it's inside, then it's a horizontal reflection. We'll deal with that more later. All right, I think it's time to graph. All right, so first one here. As you can see, I'm not really even going to be thinking about what the variables were, A, B, C, and D here, or phi, phi, pho, fum, right? Just kidding, right? Omega, phi, A, and B. Okay. What's my amplitude? Well, that's the number that's out in front of my sine function here. That's 1/2. And then I'm going to make a little, that's a better 2. And then I've got my period. Well, how do I find my period again? That's going to be 2 pi divided by that 1/2, this 1/2 right here. So I'm going to multiply by 2 over 1, or multiply just by 2. So I end up with 4 pi. Okay. Cool. I'm going to deal with my domain and range afterwards once I see that graph. I think it's nice to be able to see the graph. So let's go for it. Well, I'm going to put a 1/2 up here and a negative 1/2 down here. So that'll be what I'm, oscillating, I like to say, right? Going back and forth between. And then I got to figure out some of my values to plot on there. All right, so there's no phase shift. So I'm still starting at 0, 0. And you see what I did is I went by pi over 2s, right? That was what our initial parent function did. It went by pi over 2, pi, 3 pi over 2, so on and so forth. But we do notice that what kind of transformation is this? If it's inside and it's between 0 and 1, that is a horizontal stretch by a factor of 2. So you got to take the reciprocal. That was what that movement was, right? That's not just something that I learned from TikTok. That was a reciprocal move. It could be on TikTok. You could put it on, I don't know. All right. So it's a stretch by a factor of 2, meaning it's going to take twice as long to repeat itself. Well, if it would normally take 2 pi to repeat itself, because that's the period of a sine function and a cosine function, now it's going to take 4 pi, as we see from our period, right? So if I plugged in pi in here, I'd get pi over 2, which I know is going to be our 1, but it's then has a vertical compression by 1/2, so then that point's going to be right here. And then if I plugged in 2 pi, that's when I would get pi inside the function, right? Because 2 pi times 1/2. And then so on and so forth. I'm going to follow that pattern. But what we would see, and I'm going to pop this on here in just a sec. So I've got everything connected here. And what I did is I put a light green dashed parent function of sine. Okay. And these are all just 1 period graphs with my arrows showing that it goes on forever. But what you see here is 2 things. One, the solid darker green took twice as long to repeat itself. And also it was smushed down vertically, right? It's a vertical compression is what happened there. Okay, so two things happening there, right? A lot of this stuff is like pattern recognition and graphing it with that, but I did want to point out that it's not like it's always the same graph, same length, where we just scale it differently. It's hard to see that. So what I did is I scaled it the same as our normal parent function, and then graphed it that way, showing that it's taking twice as long to repeat itself as compared to the parent function, that dashed light green one. All right, so now let's do our domain and range. Our domain of that solid green, it goes on forever and ever and ever, is going to be negative infinity to infinity. And then our range, it only goes up to 1/2 and down to negative 1/2. So we are at negative 1/2 to positive 1/2. There we go. Woo, that's good stuff. All right, let's pop down to the next one here. Oh, this looks just wonderful. Well, amplitude. First off, it's not -2, right? It's +2. Always positive. That negative is a reflection. Okay. Our period. Well, how do I find my period? Once again. So my period, again, is going to be 2 pi divided by that bad boy right there, which is 3 pi. Oh, this is just going to be wonderfully awful. So I'll cancel those pi's, and my period is 2/3. Wonderful. Wonderful. So now we need to scale this thing out. Now I'm going to go with a different approach as opposed to the last one, because the last one played out very nicely in showing the horizontal stretch that occurred. So I wanted to take that opportunity to do that. Well, now let's think about this. I section these things off into, really, look at our previous one. We really have like 4 sections going on, right? We've got this section here, 1, 2, 3, and 4, right? We got 4 sections. So how about I divide my period, which is 2/3, I'll divide that by 4. So if I take 2/3, dividing by 4 is the same as multiplying by 1/4. So I get 2/12, or 1/6. Okay? So that's what I'm going to use for my tick marks. Every 1/6. So I've got 1/6, 2/6, which is 1/3, 3/6, which is 1/2, 4/6, right, which is 2/3. And there's one full period. So once again, in case you missed that, this was 1/6, this was 2/6, not 2/3. This was 3/6, and this was 4/6 right here. Okay, take a sec there. Those are all reduced, right? We don't want to put non-reduced fractions in there. There's just this, you got to be a class act here, right? So I reduced them all. Cool? Awesome. I'm going to get them out of the way because that's just busying it up. Awesome sauce. All righty. Now I think it's time to, we should probably scale out our y-axis as well. I'll go 1, and then 2, -1, -2. All right. Now with cosine function, I would normally start up at +1. But because I have an amplitude of 2, I would be starting at 2, but I also have a reflection, so I'm going to be starting at -2. And now I can follow that pattern, that behavior of a cosine function. I'm going to come back to the midline at 1/6. Then I'm going to hop back up to my max, local max, and then back to the midline, and then boom, back down to 2/3. So I do like to graph using the pattern recognition and all that. The last one I just wanted to show that stretch and what's going on with those points. Okay, so let's go ahead and connect the dots. I'm going to do that when I pause it in case I screw it up. Okay, it was a decent job. It took me a second try, and I just decided to go with it. It's a little tough on these touch screens here with the little Surface Pen. All right, so we got our it looks like a cosine function that's been reflected, right? So that's all good, fine and dandy, wonderful. I graphed one period of it. You could graph more if you want, but I'm just focusing on that one period. Domain, our domain, because it goes forever to the left, to the right, we are going to be negative infinity to positive infinity. The domain of every sine and cosine function is going to be just that, negative infinity to positive infinity. Okay, it starts once we get into the reciprocals, we get to tangent, cotangent. That's where you're going to start seeing different domains. Now for our range, how high and how low does it go? We've got from -2 to +2. I don't know why I started drawing an infinity. There we go. Wonderful. Fantastic. Time to move on. All right, we have a graph f of beta equals 3 cosine pi over 6 beta minus 1. So again, random variable change, right? Sometimes it's theta, sometimes it's beta, sometimes it's x, whatever. It's a variable. Okay, so we use different variables all the time. Well, let's see. Our amplitude. Amplitude is going to be 3. Our period. I'm going to need to do 2 pi divided by pi over 6, so multiplied by 6 over pi, and throw that over a 1-ski there if you'd like. If you're, a little bit afraid of the fractions. I don't know why I put a 12 there. That should be a pi. That was strange. There we go. All right. Perhaps I was looking ahead. Pi's cancel. 2 times 6 is 12 over 1, or just 12 for my period. So in what we did last time, I'm going to take that 12, I'm going to divide it by 4, and that gives me my notches, right? So I'd divide 12 by 4. That would give me 3, so I'd have 3, 6, 9, 12 for my scaling. You could go every other if you so choose. I'm going to do this right here for this one. And then I need to also scale my y-axis. So I'll go by ones. 1, 2, 3, 4, and -1. Okay. Now, we've got something different going on right there, don't we? We're subtracting 1. Well, what does that do? That's going to shift our graph down 1. It's going to take that midline, in fact, that we referenced earlier. It's going to take that midline and move it down 1. So I'm going to do that in light blue with a ruler. All right, so there's my fancy ruler. That's pretty awesome. Okay, so we got our midline sketch there. Now I'm going to start plotting some points. All right, I'll go dark blue on this. So my amplitude's 3. This is a cosine function, which means I would normally start 1 above my midline, but now I'm starting 3 above my midline, which would put me up here at 2. So once again, I do like to go by the pattern of our sine and cosine functions. Now I would come back to my midline. Then I'd go 3 below the midline, which would put me at -4. Be careful with that since we have the midline here. It throws off the numbers that we're at, right? And then I'm back to the midline and then up at the 2. Awesome. Time to connect the dots. Should I just try to do it? Let's try to do it. No fear, Mr. Allen. There we go. All right. There we go. Perfect. Wonderful. Fantastic. Definitely looks like a cosine function that's just been stretched a little bit. And actually also, stretched a little bit this way too, right? Okay. Cool. Wonderful. Fantastic. What's our domain here? Again, -infinity to +infinity. And then we have our range. This time it's a little different. It's going from -4 up to +2. Lovely. Awesome. Fantastic. I think we're just loving this here. We're loving it. All right, so let's go to this next question. Find an equation for a sine function that has an amplitude of 4 and a period of pi. Well, I already know it's going to be y equals 4 sine, but this is the part that's a little bit trickier. All right, so normally I have the number that's going on inside the function, right? And I would do 2 pi divided by that number gives me my period. But now I have my period, so I have pi equals 2 pi divided by that omega, or it would have been b in other textbooks, right? So now I can just solve for that. So if I multiply by that omega, or b, whatever variable you're using, and then I would divide by pi. That's a little. I feel like that's a little sloppy math here. I should rewrite that. Come on, Mr. Allen. And when I divide by pi, we can see that those pi's are going to cancel. So my period multiplier is going to be just 2. So 2, and then it doesn't give us a variable, so we can just go 2x, or if we wanted, we could go 2 theta if we want to be cool, right? Awesome. There we go. That's all we needed for that one. Not too bad. All right, so write the equation from the graph below. Okay, so what kind of characteristics are we looking at here? Well, first off, I can see it goes up all the way to, that looks like positive 4 right here, and goes as low as then negative 4. So that clues me into the amplitude being 4. So I'll write that down, amplitude of 4. And then how long until it repeats itself? Well, how about I just start, since it's up here, I like that as a starting point. And then once it gets back up to that local max, we'll call it, it looks like it took 4 pi. So the period is 4 pi. That's how long it took. Then it's going to just repeat itself again and over and over and over, right? Okay, cool. So I've got my period, I've got my amplitude. It's starting on that y-axis. So there is no phase shift. We haven't really dealt with that yet in this particular class. So I think we got all the information we need, except I do need to find my period multiplier, just like we did in the previous problem. So I'd have 4 pi is equal to 2 pi over, it'd be either omega or, oh, you know what, I'm going to use B this time just because I'm crazy like that, right? Some textbooks use that, or the online book uses omega instead. And then I'd multiply by B, so now I have B times 4 pi is equal to 2 pi, divide by 4 pi. The pi's cancel, that's all gone, and that reduces to 1/2. So now I'm ready for my equation for this one here. I'll change colors so it doesn't get lost. And we'll go with y equals 4 sine of, or sorry, not sine. Whoa, we're starting above. This is a cosine that I'm using. And then it would be 1/2 theta or 1/2 x, whichever variable you want to use. Good to go. Wonderful, fantastic, awesome. I like it. Okay. You could write this as a sine function, but you need to use a phase shift, which we haven't really dived into yet. I don't know if any of those were right. Okay, let's keep going here. Next one. Same idea. So I'm going to start on my y-axis so I don't have to do a phase shift, which would be right here. It starts by going down to, it looks like -2 and +2. Okay, so there's no vertical shift. So that would mean my amplitude is 2. How long does it take to repeat itself? It goes all the way, let's see here, and we're back at that spot right there. So this is looking like a sine function, but it starts with negative, so we do need to remember that too. It's got a reflection in it. All right, but it looks like my period took all the way to 6. So now let's find our period multiplier. We'd have 6 equals, because that's my period, 2 pi. Oh, should I go back to omega? What's up? I'm crazy. Look at that. I'm like a crazy mathematician just making up random variables to use with the intent to scare children, high school children, thousands of years later after they have to take these classes. Okay. So divide by 6. And I get omega equals pi divided by 3. So there's my period multiplier. I'm ready to write this one. Again, I'm going to switch colors. I'm going to go with red. So I've got y equals -2, and we said it was a sine function because it's starting on that midline, in this case at 0, 0. And then we have pi over 3. And I'll go with x this time. Cool. All right. I like it. Fantastic stuff right there. Let's keep going. All right. For this one, to save time, I'm just going to let you guys pause it, try it, write the equation, and then I'll toss the information up there. So go ahead and hit pause. I said hit pause. Hit pause, pause, pause. All right. Hopefully you guys got that right there. Y equals 4 cosine pi over 2 theta or x or whatever. All right, whatever variable you chose. Okay, next one we're going to do is one from the book or from the online homework, just because they can get kind of a little bit nasty, right? And you can see how they format these things. Find an equation for the graph shown to the right, below, in this case, below, so it could fit a little nicer. Type the equation in the form y equals a sine of omega x plus b, or y equals a cosine of omega x plus b. So they tell you the formula essentially with their variables that they choose to use, whereas some textbooks would use b in place of that omega. This is what our online textbook decided to do. All right. So type the exact answer using pi as needed. Use integers or fractions for any numbers in the expression. All right. So how long does this one take to repeat itself? We got to find our period. We got to find our amplitude. Well, it looks like my midline is at 1. Okay. And we've got it from here, and then it comes back down right over here, right? We're avoiding those phase shifts for now. So it's, we have a period of 3/2. Looks like I have an amplitude. It's going above by 1 and below by 1. So amplitude of 1, and then a period of 3 divided by 2. So how do I find my my period multiplier? Well, I would have 3 divided by 2 equals 2 pi divided by omega, multiplied by omega, and some of you might also notice that each time we're just dividing by, we're either doing 2 pi divided by that period, or 2 pi divided by the period, or 2 pi divided by the period multiplier if it's an equation. And yes, that algebra will work out that way each time. I'm just showing it because I'm crazy apparently. So I have 2 pi times, it'd be multiplied by the reciprocal, right? Times 2/3. So I'm going to get 4 pi divided by 3. So we have all the information that we need, right? I've got my amplitude. I've got my period multiplier. Let's pop it in. Well, this one starts below that midline, and this is a cosine function. So y equals negative, and then our amplitude was 1, so just cosine of 4 pi divided by 3, and then we're using x per the book, and then that midline's plus 1, so plus 1, and that would be how I'd enter it into my math lab. Awesome. Fantastic. No need to include the 1. I don't know if it would mark it wrong if you included the 1. I don't think it would, but if it's a 1 for my amplitude, you wouldn't write it there. All right, the only other thing we wanted to cover in here is how to enter into my math lab if you're going to graph it. All right, I made a little video. It's linked in the weekly preview there. How to graph it. I'm going to link it in the Edpuzzle if you're watching this on Edpuzzle as well. It's just a quick 3-minute video on how to use some of these tools here. Feel free to just pause and take a look at this, and if you want to watch the other video, you can. Otherwise, you guys have a wonderful day. America Freedom, rock and roll Costco, Riverdog Jenny on the gram. Have a wonderful day. Thanks for tuning in.